Students, in previous class discussed about some general properties. Now today also going to discuss in this video also continue the remaining properties. So what is the next property? Oxidation states. So oxidation state of this group elements exhibits various oxidation state. -3, +3 and +1. These are the common oxidation states of this group elements. Even though here -3 oxidation tendency in downs the group decreases. What happened? -3 tendency downs the group decreases. As well as due to you are increasing the size and metallic character. Why here -3 oxidation state downs the group decreases? Increasing of size as well as metallic character. That's why the tendency of -3 oxidation state decreases. So that is order is about nitrogen, phosphorus, arsenic, antimony and bismuth. Especially bismuth does not exist as the -3 oxidation state. It is purely metallic character. Like that. Next, +3 stability. Here downs the group +3 stability increases. Stability point of view I am discuss. Here stability increases. But whereas +5 stability downs the group decreases. Why? Because here children, reason is inert pair effect. What is the reason? Inert pair effect. So what is inert pair effect children? The reluctance of the outer shell electrons, NS2 electrons in the bond formation. Reluctance of the outer shell NS electrons in the bond formation is known as inert pair effect. You know electronic configuration, general electronic configuration of this group NS2 NP3. That means these outer shell NS electrons are reluctance for bond formation. Only these 3 electrons are ready to the bond formation. That is why here +3 stability increases, but +5 stability downs the group decreases due to reason inert pair effect. Whereas especially in this group of nitrogen elements exhibits the multiple oxidation states along with these 3 element oxidation states exhibits other oxidation states also like +1, +2 and +4, even +5 also exhibits oxidation state with oxygen, especially with oxygen. It exhibits the nitrogen element oxidation states. Why? Because here nitrogen is a more electronegativity element, as well as here it exhibits the multiple bond formation. That is why here nitrogen forms here variable oxidation states with oxygen. But even though phosphorus molecule also exhibits the +1 and as well as +4 oxidation states in oxoacids. Here is your oxoacids. Oxidation state of your phosphorus. Next, valency. In this group of elements, nitrogen exhibits the maximum valency. How much, children? Maximum valency. That is covalency. Here maximum valency is 4. I will give the example. Maximum valency of compound is here nitrogen NH4 plus. Then what happened here? Nitrogen formed by how many bonds? 4 bonds are formed. That is here 4 bonds. These 3 are covalent bonds. This is called day-to bond. Nothing but your nitrogen, lone pair of electron. This lone pair of electron is donated to H plus ion. H plus ion means you are completely available of vacant orbital. That's why your nitrogen element exhibits maximum valency 4 only. But whereas other elements exhibits the valency up to 5. Due to here, what happens here? Phosphorus, arsenic, antimony. These elements are exhibits the maximum valency how much children? 5. Why? Because these elements are available of vacant d orbitals. I will give one of the example of the compound here. PF6 minus. Phosphorus hexafluoride ion. Here the phosphorus maximum valency is how much children here? 5. That is the available of maximum valence here, formation here up to 5 only. So this is the about the oxidation state as well as covalency. Okay children. Next about So these are the general physical properties of 15th group elements. Okay children? Next, here one more concept, anomalous properties of nitrogen. Here nitrogen element showing anomalous properties. Anomalous properties means abnormal properties. Here special properties when compared to rest of the elements, that is called anomalous properties. So you know, every group the first element shows anomalous properties compared to rest of the elements, because your reasons are, what is the reason for your anomalous properties of nitrogen? One is called small size, second one is about high electronegativity, and third one is about your high ionization potential, and fourth one is about available of absence of d orbitals. Absence of d orbitals. Due to these reasons, in this group nitrogen exhibits the anomalous properties. Okay children? Now what are anomalous properties? Now here one of the, I will give you some examples of anomalous properties of nitrogen. These are the reasons for anomalous properties. But what are properties of anomalous property here nitrogen? Here the anomalous properties of nitrogen, one is mainly here important is nitrogen only forms here p-pi multiple bonds. P-pi multiple bonds. But it cannot form p-pi d-pi multiple bonds. It cannot form p-pi d-pi multiple bonds. It can form only p-pi multiple, because of your nitrogen element is absence of d orbitals. Okay children, that is the main important of anomalous properties. And also here nitrogen elements here exhibits the multiple bonds, that is about triple bond, but remaining elements exhibits are single bonds with same elements. Nitrogen to nitrogen triple bond, but whereas phosphorus to phosphorus single bond, arsenic to arsenic single bond, like that antimony to antimony single bond, but here exhibits a triple bond formation for nitrogen. And also already studied here, nitrogen valency shows up to 4 only, but remaining elements are shows the valencies of more than 4 also. Okay children, so like that, one more property. Here nitrogen formation of the halides. Here nitrogen forms halides up to trihalides only, that is representation NCl3, but it cannot form NCl5 pentahalides. But whereas phosphorus, arsenic, antimony, these elements are exhibits the pentahalides also. Why? Because here phosphorus, arsenic, antimony is available of vacant d orbitals. That is why it is also one of the special anomalous property of here. Nitrogen form only trihalides. It cannot form pentahalides. But other elements are forms pentahalides also. So that is also one of the anomalous property of nitrogen. And one more point also already studied here. Oxidation states. Nitrogen forms various oxidation states up to here -3 to 2 up to +5 formation. Why? Because here nitrogen is the high electronegative element, and also here exhibits the variable oxidation states. So these are the some of the anomalous properties of nitrogen children. Next, go to here discuss about the some chemical properties. Chemical properties of this group of the elements. Here chemical properties means here reacts with other elements. For example, here action with now first here discuss about action with hydrogen. So what happened? Here action with hydrogen, formation of hydrates. Here formation of hydrates, representation of the formula, general formula MH3. What is the formula? MH3. So here formation of hydrates are like NH3, PH3, here ASH3, here SbH3, BiH3. These are called hydrates of 15th group elements. These are named as, first one is ammonia, this is called phosphine, this is called arsine, this is called stibine, this is called bismuthine. These are the formation of hydrates. Now we have discussed about some properties of your hydrates only. This is representation of general formula. Now your first point is about preparation. But how to preparation of these hydrates? These hydrates are prepared by binary compounds. Binary compounds undergoes hydrolysis or reacts with acids. What happened? Binary compounds undergoes hydrolysis or reacts with acids to form the corresponding hydrates. Children, I give some example here. One of the example is can taken as here. Magnesium nitride. This is binary compound of nitrogen. Magnesium. Binary means here bivalent. Here you know magnesium is a second group element, that is why bivalent. Magnesium nitride. It undergoes hydrolysis, H2O. Then what happened? The product here 2 moles of ammonia plus here byproduct is of magnesium hydroxide. Okay children, like this. Like you can take one more compound also. Ca3P2, calcium phosphide. It reacts with acids also. Suppose if you can take hydrochloric acid, the product is 3 moles of CaCl2 plus here 2 moles of PH3. Phosphide is formed. That's why you can take here 6 moles of HCl. So I give some examples for preparation of ammonia, preparation of phosphine. That's why you taking the compounds are always binary compounds like magnesium nitride, calcium phosphide, zinc arsenide or zinc stibinide, calcium bismuthide, like that. It undergoes hydrolysis or reacts with hydrochloric acid to form the corresponding hydrates. That's why here preparation of hydrates, you are using either binary compounds undergoes hydrolysis or reacts with acids to form the hydrates. Okay children. These are preparation methods of hydrates. Like that. Here are some of the properties of hydrates only. Here, one of the property here, observed here, stability. What happens here, stability of hydrates? Here, down subgroup stability decreases. That means which is more stable hydride? NH3, PH3, here ASH3 and SbH3. Next to BiH3. This is order of stability. Like that. Here basicity. That means basis or order of basic nature. Not basicity, basic nature. Here the basic nature also downs the group decreases. Here ammonia is of more basic nature. Like that. PH3. Here ASH3, SbH3 and BiH3. This is order of basic nature. Next, distance. Distance between M and H. M and H means M is 15th group elements, here hydrogen. The distance is what happened here? Increases. Why? Because size of the atom, central atom increases. That's why the distance also increases. Next here, formation. Enthalpy of formation. So now children, your enthalpy of formation also, what happens here? Increases enthalpy of formation. Next here, enthalpy of dissociation, delta H dissociation. Here dissociation, what happened? That is also in between M and H. Here dissociation is decreases. You know, which is the more stable? Ammonia is more stable. That's why the dissociation of your NH bonds is difficult. Whereas BiH3 is stability is less. That's why here easily dissociation of Bi and H bonds. That's why bond dissociation enthalpy down subgroup what happened? Decreases. Like that. And bond angles. Here one more property is about bond angle. Bond angle is here generally decrease in downs the group, but ammonia is more bond angle, because here lone pair bond pair repulsions, here ammonia is exhibits a high bond angle. Around here ammonia bond angle is 107 degrees, but whereas PH3 here bond angle is 92 degrees, here ASH3 here bond angle is 91 degrees, SBH3 bond angle is 90 degrees, like BH3 bond angle is nearly 90 degrees. Now here observe children, here 107 degrees in ammonia, but remaining elements hydrates are mostly constant, 92, 91, 90 only. Here also what happened? Here involving of the bond formation in ammonia molecule is pure orbitals, but remaining are involving hybrid orbitals. That is why here bond angles what happened? Gradually here decrease, but ammonia is the highest bond angle. Next, boiling points. What about the boiling points as well as melting points in hydrates? Boiling points and melting points of hydrates. Here boiling point here also decreases. Boiling point is decrease, but here also ammonia is the more boiling points. That is why here order of boiling points PH3, here ASH3, and then next is about NH3, next is about SBH3 and BIH3. This is order of boiling points. Your expected boiling point of ammonia is low, but your boiling point of ammonia is more than that of phosphine and arsine, due to your ammonia molecule exhibits the hydrogen bonds. That is why your boiling point is high, like that. Melting points. Your melting points also what happens? Decreases downs the group. But here also ammonia is the high melting points. Here order of melting points are here PH3, ASH3, SBH3, and next here about NH3. Order of melting points. Next, one more property children, reducing agents, that is reducing power. Here the reducing power is downs the group increases. That means here comparison of your hydrates NH3, here PH3, next to ASH3, here SBH3 and BIH3. So and finally here bismuthine is the strong reducing agent, because of bismuthine is the less stable, can easily dissociated into bismuth and hydrogen. It is readily producing of hydrogens. That is why the reducing power increases. So and finally children, which properties are increases here? Reducing power increases and enthalpy of formation increases, whereas so these are the two properties are here what happened? Increase, but remaining all the properties are what happened? Decrease. Remaining what properties? Stability decreases, basic nature decreases, distance dissociation enthalpy decreases, boiling points decreases, melting points decreases, bond angle also decreases. Only increasing reducing power as well as here enthalpy of formation, and also one more is also distance between central atom and hydrogen. Only these three properties are increases in the downs the group in hydrates. Okay children, so that is the hydrates information. Structure of hydrates. So what about structure of hydrates? Here generally here representation of structure of hydrates is MH3, here hydrogen, here hydrogen, here hydrogen. This position is containing lone pair. That means here all our shapes are here pyramidal shapes. All are pyramidal shape. All our central atom undergoes sp3 hybridization. But bond angles are here varies. Already discussed about bond angle property. Okay children. So this is about the properties of hydrates. This is one of the chemical property of 15th group elements. Next, action with oxygen. What about children? Action with oxygen. So what happens here? Oxygen, action with oxygen. Here mainly forms the two types of oxides. Two types of oxides. So what are two types of oxides commonly? One is M2O3 type of oxides. M2O3 type of oxides. One more is about M2O5 type of oxides. In M2O3 type of oxides, the oxidation state of M, how much children here? Plus 3. The oxidation of M is how much children? Plus 5. Here, observe the properties of your compounds here. N2O3, here P2O3, here AS2O3, Sb2O3 and Bi2O3. These are the trioxides. But whereas pentoxides are here N2O5, P2O5, here AS2O5, Sb2O5 and Bi2O5. So children, here especially here phosphorus, arsenic, antimony, these three oxides are exist as the dimer. Dimer means here exist as formula P4O6, here AS4O6, like that. It is also Sb4O6 dimer formula. Like that here also, these are also exist as a dimer state P4O10, here AS4O10, like that. Here also Sb4O10. Here phosphorus, arsenic, antimony exist as the dimer state. But bismuth is exist as the monomer state, like that. Nitrogen oxides also exist as the monomer state. Here also observe here, first two oxides are here acidic nature, but remaining these two oxides are here amphoteric nature. Nothing but here exhibits as the acidic character as well as basic character. But Bi2O3 exists as the basic character. Because here nature of the elements are changes from non-metals to metals. Like that here also, first two oxides are acidic nature, next two are amphoteric nature, the last one is what is nature? Metallic nature. So that is why these are also here acidic nature is what happens? Decreases. Okay children. So decreases, but basic nature down the group increases due to change of the nature of the elements. Okay, that is action with the oxides. These are also, especially your N2O3 is exist as only monomer, like N2O5 is also exist as monomer state only. So these are the oxides. Next, like that, your action with the halogens. Action with the halogens. So now action with the halogens. So here also forms the two types of halides. What two types of halides children? Here one is called representation AX, that is here also representation is MX3, and one more is about MX5 type of halides. So one is MX3 type of halides, second one is MX5 type of halides. Already it is, children, you know, here nitrogen forms only MX3 halides, that is like here NF3. Here phosphorus forms, here it does not form pentahalides. Phosphorus forms here PF3, PCl3, here PBr3, like that. It is also forms PCl5, PBr5, like that. Arsenic, antimony, bismuth, these all are forms of trihalides. AsCl3, like SbCl3, BiCl3 formation. Like that here also here AsCl5, SbCl5, here BiCl5. But here BiCl5 is unstable. So what happens here? Observe children here. Nitrogen does not form pentahalides, but other elements are forms the trihalides as well as pentahalides. In especially bismuth pentahalide is also unstable. Here especially bismuth formation of trihalides, BiF3 is a ionic nature. This is one of the important points, children. In trihalides, bismuth trifluoride is of ionic nature, but whereas remaining trihalides are covalent nature, as well as pentahalides also covalent nature. Here comparison of covalent nature, pentahalides are more covalent nature than trihalides. Why? Because your oxidation state is +3, your oxidation state is +5. Generally, increasing the oxidation state of the central atom, your covalent nature also increases. Okay, children. So, here BiF3 is ionic nature, remaining halides are covalent nature. That is and also here NF3 only a stable halide, but remaining trihalides of nitrogens are unstable. That is NCl3, NBr3, these are unstables, but this is only stable form. That is here formation of action with halogens. Next, children, here action with metals. Action with metals. Here action with metals of this group elements to form the nitrides. So especially here form the binary compounds. So these nitrides here exhibits the oxidation states or -3 oxidation state. So examples of compounds here Mg3 and 2, here like that magnesium nitride, calcium nitride, Ca3N2 and Ca3P2, like that here Zn3 Sb2 and Na3 etc. And Mg3 Bi2. These are examples of your binary compounds. These are formed the compounds are here reacts with metals, forms the nitrides. Here nitrides means metal triads. In this compounds exhibits the oxidation state is how much here? -3 of the element. So especially these are the nitrates formation action with metals. Okay, children. So these are the chemical properties of your 15th group elements. Okay, children. So these are the nitrides, metals, action with metals, action with halogens, action with oxygen, action with hydrogen. These are the general properties of this group of the elements. So children, in this group, the most important element is nitrogen as well as phosphorus. That's why in this chapter, next go to discuss about the nitrogen element. Here nitrogen element means a study of how to preparation of nitrogen and what are the properties of nitrogen as well as what are the importance or applications of nitrogen, as well as study of nitrogen compounds. One of the most important nitrogen compound is ammonia as well as nitric acid. That is also how to preparation as well as properties of ammonia and nitric acid. So these are the study of in this main importance of nitrogen compounds as well as phosphorus compounds also, and as well as structures of here oxo acids of phosphorus. Okay, so that is the importance of your study of in this chapter, children. So next class go to discuss about the here preparation and properties as well as applications of nitrogen. Okay, children.